Let's go.
You're listening to Making Data Simple, where we make the world of data effortless, relevant, and yes, even fun.
Hey, podcast listeners, Al Martin here. Thank you for listening to Making Data Simple. As always, I'm just going to jump right in today. I have with me Ronen Dar, who is the co-founder and CTO of Run.ai. Ronen loves academia. He loves startups. He loves taking part in the AI revolution. So today, the topic is really going to be just that, AI. What's your background? Tell us a little bit about yourself.
My background before Run.ai, I did both academia and both startups and companies, serving both in the industry. So I did industry and academia in parallel. I did my master's, PhD, and postdoc in information theory. So I learned a lot, studied a lot of ways to how learning systems are working, how to measure information in data, how to extract information from data efficiently, so things like that. So that was in the academia. In parallel, I worked in companies, in chip companies actually here in Israel, mainly for a startup that we developed a chip that runs on top of storage, flash storage, and improving flash storage, allowing to store more bits into the flash storage. And so over there, I learned how it is to build, design chips. And so my background is, combining software and hardware experience, and combining both academia and industry. And I brought that experience to Run.ai, right? So with Run.ai, we're in the AI space, and we're really coming from the bottom, from the hardware, building software stack, building a software company that really is attached to the hardware and those accelerators for AI like GPUs.
Now, how long have you been with Run.ai? Or how long have you founded the company? How long has it been in existence?
So we started in 2018. So it's me and my co-founder, Omri. We know each other from the academia, and we actually had the same supervisor, both of us, and with our supervisor, the three of us started Run.ai a little bit more than 5 years ago. And we knew that we want to be in the AI space. We saw back then, when we did the ideation phase, we saw that there were these amazing capabilities of AI. There is a technology here that is going to change the world, and we knew that we want to be part of it, right? We want to help to change the world with AI. So we also saw that hardware is really critical for AI applications. You need a lot of compute power for running AI workloads. And we saw that the cloud was actually built for running microservices, running applications on commodity CPUs, while AI is really compute intensive. It needs a lot of computing power. It runs on those AI accelerators like GPUs. Those GPUs are really typically scarce and expensive. So the software stack that runs on top of those GPUs, we saw the gaps over there. We saw, the inefficiency in how hard it is to manage and orchestrate infrastructure and actually utilize well infrastructure for AI. So we went into that, and we decided to cover those gaps and build a software stack that runs on top of GPUs and actually provide like a software platform for AI companies.
Could you kind of predict the future then? Because you've been doing this since before AI was cool. Now, I'm from IBM. We've been doing it for some years, for forever. In fact, back in the 50s. It depends on how far you want to go. But look, what the Transformer comes out in somewhere around 2017, 2018. What predicated your founding of Run.ai?
Oh, great question. So I think I really believe in trends, right? My father was an investment broker, so he taught me on how to look on trends, right? On how to identify trends. So trends are important, and I think we saw back then the trend of bigger models being developed, using more data, using more compute, and we saw that there are three big components for AI: compute, data, and algorithms. And having those three, right, like you can create AI. And since 2012, 2013, we're seeing this trend of more and more compute power required to train state-of-the-art models. In 2012, 2013, researchers from Toronto actually started this big breakthrough in AI with deep learning in the industry, with with the ImageNet computation training AlexNet on 2 GPUs. So the big new thing that they did is that they showed how a bigger model with more parameters, can be trained by just using GPUs instead of CPUs, and actually accelerating the training time and getting to results faster, and actually being able to train those big models and getting to amazingly new, better results. And so back then, the state of the art was to train using 2 GPUs. 10 years later, right now, GPT-4 was, according to rumors, trained on more than 20,000 GPUs. So
Yeah, you got to have a few bucks for that, right?
yeah, exactly. And GPUs became much better also, right? So actually, people in the academia studied that trend of more and more compute required to train state-of-the-art models. They figured out that in the last decade, 100 million x increase in compute power is required to train state-of-the-art models. 100 million x increase. So that's like mind-blowing. So I think that trend is really important.
Yeah, very good. Thank you. So, look, as I jump in here to some deeper questions, I think it's fair to kind of set this up. And that is Allie, who is, I'll call her the broker. She's listening quietly right now. She had listened to our podcast on Luke Aragoni, who discussed AI ROI insights and challenges. I would encourage the listeners to go back and listen to that one. It's pretty good. And we were talking about some of the biggest blockers for companies, which, I mean, there were a number that we discussed, but a lot of it came down to trust within the models, which I still stand behind. She had mentioned that there was another big blocker that we didn't get into in depth, which is the GPU shortage that you just kind of mentioned. And I thought that was fantastic. We should jump into that. So I've got a ton of questions about that, and I really do want to jump in because of your knowledge. But to finish up on, well, not necessarily finish up, but to continue with Run.ai, tell us a bit more about specifically Run.ai, what your day job is, what's the tech behind Run.ai, and what's your differentiation in the market?
Okay, so my day-to-day actually changed a lot since we started, right? So what I did 5 years ago is totally different than what I'm doing now. And I think the role of the CTO really depends on the CTO, right? On the character and the personality and the skills of the CTO. So it's like, I think it's in startups, at least, it's very fluidic role. There are CTOs who love to code. They are software developers. They will code anything, right? They just love to program, and they will build like a big parts of the product itself. There are CTOs that are more oriented to product or more oriented to marketing or sales. Like, it really depends on the CTO itself. I think for me, it's like I came from the academia, so I came with a research background. So I love research. So a lot of what I did in the past, and I'm still doing, is research. I have my own team, and we're doing amazing research right now on LLMs, on large language models. I think there is LLMs is a new market actually now, with new challenges and new technology that needs to be developed, new challenges, new problems, and we're researching those problems, really understanding them well, and trying to find new solutions, unique solutions. Right now, I'm doing a lot of research. I'm working very closely also with the product teams and marketing teams here in Run AI. And for us, because we wanted from the early beginning to be unique and develop deep technology, right, and to solve problems in a profound way. So for us, the problem that we identified is the problem of orchestrating resources for AI, orchestrating compute resources like GPUs and actually utilizing them. So current tools were built, Kubernetes, for example, the cloud native framework for orchestrating containers, right? Kubernetes, it's an amazing tool. It was built around 2015, but it was built for running microservices in the cloud on commodity CPUs, right? So you're getting with Kubernetes a lot of tools when it comes to load balancing, auto scaling, microservices, doing things like that. But when it comes to AI, there is a need of running jobs, really compute intensive jobs on maybe multiple nodes of GPUs. So a lot of actually scheduling capabilities were missing. The default scheduler of Kubernetes is really provides some amazing capabilities, but some very important capabilities when it comes to batch jobs running, like batch compute intensive training workloads are missing, like I won't get into the details, but about batch work and a gang was scheduling, sharing resources with preemption and with queuing and things like that. So a lot of scheduling capabilities are missing. So what we've built in Run AI is a scheduler that we plug into Kubernetes environments. And we essentially extend the capabilities of the default Kubernetes schedulers to bring all the scheduling capabilities that are missing for running AI workloads in the most efficient way. And so that's one thing. The second technology component that we've developed is this GPU optimization layer, where we sit at the CUDA layer. And what we do is we intercept CUDA API calls, and we essentially control access to GPUs. And we enable multiple workloads to share the same GPU, and essentially over provision GPUs. So over provisioning is really known and is available for CPUs, but it's not available in the vanilla Kubernetes way. So we're enabling that with that component. So essentially, we're bringing those two pieces of technologies, and we're bringing more efficiency into Kubernetes environments for AI. So we started from that, and then we've built tools for platform engineers, for infrastructure engineers to control AI infrastructure, to control how resources are being allocated, to control how resources are being utilized. And we built a lot of tools for developers and data scientists to essentially train models very easily and deploy models very easily. So we've built a lot of tools around just abstracting Kubernetes and abstracting all the infrastructure complexities when it comes to just running those AI workloads. So we've built all of that software layers, and we're bringing it to AI enterprises.
So let me see if I can summarize what you said. Basically, you're working to accelerate AI development in those large language models, cost optimization, cluster management, workflow management. And it's a platform. Tell me if this is right or wrong. It's a platform that drives model deployment, model training, infrastructure, which includes Kubernetes in a hybrid cloud environment. Did I do okay? Somewhere around there?
Yes, I think you did. Yeah,
Pretty
I think
good.
you did. It was good.
You know why I think I did okay is because a lot of what you have there is kind of IBM's strategy as well. So I think we align at least on strategy. That's terrific. Let me add one more question. What differentiates Run.ai? And if I'm a listener out there, when should I think, or how should I think, I need to engage Ronen and his team at Run AI?
I think what's happening today in the cloud is that it's really very difficult right now to get access to GPUs, right? Like the GPU shortage is real, I think. It's still real if you're trying to spin up high-end GPUs in the cloud right now.
It's absolutely real, by the way. Yeah. I mean, it's a major inhibitor. And we'll get into that next. Yes, I'm 100%. But keep going. Sorry to interrupt.
Absolutely. I absolutely agree. It's real, and it's here. And, and if you're trying to spin up an A100 or H100 in the cloud, you might wait for days until you're getting that resource. So what we're seeing now is companies just shifting the way they consume resources in the cloud, moving to more like securing access to GPUs, reserving access to GPUs. And once you're doing that, then you want to have a way to control resources, to prioritize workloads, to have a better scheduling on those resources, because they are so expensive and they are so scarce, right? So if you're getting into a point where you want to have control over your GPUs, you want to schedule workloads and prioritize workloads, and then we'll shine, right? Then we're shining. We're allowing teams to get much more out of their GPUs, out of their AI infrastructure, and essentially, get more access to GPUs, more availability of GPUs, and essentially running faster, right? Like teams become more productive when they have simple access to GPUs, when they just can fire up jobs very easily and at scale. So teams becomes more productive, and development is being accelerated. as you said,
Sounds
and you said it. You said it well. You said it, yeah.
well, I'll dive in on several of those pieces, but so clients will come to you essentially when they need help driving some of that run AI. Or do you have entities around the world, or is it local to Israel, or do you serve any customer no matter where they reside?
Yeah, so engineering and product are mainly here in Israel. Most of the go-to-market teams are spread around, mainly in the US. So we have a big focus on the US. We have teams also in EMEA, and we have teams also in APAC, right, covering those regions. We have customers all over the world, right? Like we have big enterprises that we work with from big banks, from gaming companies, from the biggest Gen AI companies. Like I don't want to just throw names, but yeah, you can
No,
see
that
those
makes
names
sense.
on our website. Yeah.
So let's dive into GPUs. That's kind of what intrigued me about this conversation. And look, let's first start off with I know this will seem odd because everybody should know what a GPU is that's listening to this podcast. But if you could explain your definition of GPUs, it is making data simple as the podcast, and then we'll start diving down into GPUs. Why GPU? Why not CPU?
GPUs exist for the last 30 years, right? GPUs are not new in the world, right? Like graphical processing units. They were built for graphical applications, like in gaming, right? In gaming, you need to generate graphics very fast at scale. Graphics is an amazing applications where you have a lot of linear computation that you need to do, right? That's graphics. A lot of matrix multiplications and other linear calculations that you can essentially parallel very efficiently. So GPUs were built for as a parallel machine that can process amazingly fast linear calculations in parallel and essentially accelerate those type of workloads. So the main application was gaming for many years. NVIDIA had this big vision of enabling also other workloads to run on GPUs and essentially be accelerated by GPUs. So they built CUDA and they built a lot of software tools just for simplifying for developers just having a way to run applications on that GPU. It turns out that in AI, in deep learning, in language models, you have a lot of linear calculations, a lot of matrix multiplications that you can parallelize and calculate them much more efficiently and much faster than you can do on CPUs. CPUs are generic processor that can run a lot of workloads, but it's not specialized to linear calculations, to parallel calculations. So those Toronto researchers, 10 years ago, they they invested a lot of effort for running new models on GPUs and train them on GPUs. Back then, there wasn't TensorFlow or PyTorch wasn't exist, right? So it was really difficult to train a model on a GPU, right? But they did it, and then right there is a new application called AI that can be accelerated significantly 100 times, 1,000 times faster compared to CPUs, and that application just exploded.
That's kind of the key, right? You can use traditional programming techniques within AI, also for quantum, which is interesting that we're promoting here at IBM. But here's what I heard you say: so CPUs, look, we're getting faster clock speeds, additional cores, but when we need to design for parallel processing. That's where GPUs come in. They accelerated or started with 3D graphics. They started in gaming, and then they're advancing to artificial intelligence, high performance computing, deep learning, et cetera, et cetera. When it comes to training, there's NVIDIA, or there's, you can use a number of GPUs to be able to achieve your goal from, whatever large language model you're training. Big corporations like IBM, Google, Microsoft can pay billions to get these models trained. Size is going to matter in the future, particularly on the inferencing side, where clients have to have a number of GPUs to be able to inference correctly. And I don't think that's commonly known once you take the large language model. So, our strategy here at IBM, by example, and it's a strategy I believe in, is, size does matter. We're going to have smaller, more purpose domain driven models to be able to keep that cost low. But we're still at the age of giant AI models right now. So I don't know where you think we're headed, but I think we're going to have to reduce those models significantly and like the IBM strategy. But look, I'm up for counter opinions. Otherwise, this isn't going to be scalable for our clients.
Yeah, I think your point on size is really important. And I think you can view it in different ways, but size in AI is important. So first of all, I think like, the past showed us that bigger is better in AI, right? Bigger models mean better results, models that can solve bigger problems, more complex problems. I also agree with you that once there is a use case which you can solve with AI, and there is a specific task that AI can solve, then it doesn't make sense always to use gigantic model, right, to solve that specific task, right? So when it comes to specific task, I do see how companies, right, like will shrink their models, make them more specialized into that specific task, so they can run it more efficiently, so the cost will be lower. In the future, what I'm imagining is that innovation and new results will come from building new models, bigger models, right? Like bigger models with more parameters that can do new stuff. But we will always see also this trend of taking specific tasks, specific use cases, and solving those specific use cases with smaller and smaller models, so things can become more and more cost effective. So I totally agree on that.
I'll give the listeners an example. I mean, IBM is building large models as well, like everyone. We just recently released a code gen model. I think it's actually the largest on the market right now. Of course, there could be something that maybe I haven't seen or just came out, by the time we hear this, which is right now ours is like 1.6 trillion tokens. I think 1 trillion is probably the largest one I've seen outside. We have 115 programming language, or we have 20 billion parameters. I think there's like 15 billion outside. I could go on and on. The context window is pretty large as well. But we know that, look, that's going to be an arms race. I mean, everybody's going to continue to build bigger and that kind of stuff. Our position is more in line with, again, the fine tuning, aligning with workflows, customer workflows, and getting it into a reasonable cost for clients to be able to take advantage of some of these large language models, as I just mentioned. Where do you think context windows, parameter size, where do you think that's going to evolve?
So you mentioned two things, right? Parameter size, just number of parameters. You're at IBM training models with 20 billion parameters, right? That's what you said.
Yeah.
Yeah. Okay. How many GPUs?
That's with the code assistant. We got many models, but that's just the code assistant, the code gen model that I'm referring to that we released a few weeks ago.
Got it. Yeah. So 20 billion parameters, right? Like if you're running with the float 16 representation, right? Then you need like around 40 gigabyte of GPU memory, right? For just hosting a single replica of that model, right? So if so that's like the rule of thumb, right? Like that's important for just understanding why the number of parameters in your model is important, right? Because bigger models with more parameters mean that you're doing more calculations, right? You need more compute power, but you also need more GPU memory to store those weights. Typically, common models are run with 16 bits, right? With float 16. So with float 16, the rule of thumb is that you multiply by a factor of 2 the number of weights to get the size of the memory that you need in your GPU to store those weights, right? So with 20 billion parameters, you need 40 gigabyte of GPU memory. So the new high-end GPUs, they come with 40 gigabyte of GPU memory, but there are versions with 80 gigabyte of GPU memory. So you can host one model like that on one GPU, right? If you have a GPU with 80 gigabyte of memory, so that's fine. But For example, Llama 2 comes in different sizes. It also, the bigger size is 70 billion parameters. And for 70 billion parameters, you need 140 gigabyte of memory. So for that model, you need a few GPUs just to run one replica of your model, right? Just right, processing one prompt and resulting in an answer. You need like around four GPUs just to run one prompt. So that's amazing. That's a lot of GPUs. So right, more parameters mean more GPU memory, more GPU compute that you need, and that's like it means that your model is more expensive. Context windows, same thing, right? You have longer context windows, so that can be amazing. Um, you can have longer inputs. You can, maybe send like whole documents to your LLM and ask your LLM to get insights out of those documents, right? So longer inputs is amazing. Also, longer outputs is amazing because you can ask your LLM, to produce a whole articles and things like that. So, but longer context windows mean more calculations and essentially also more GPU memory. So also your models become more expensive when context windows are becoming longer and longer. And there are some academic work being done today on context windows, on very long context windows. People are showing that LLMs are losing accuracy and actually losing their attentions when the input length is very long. So it's like it's like human beings. When you read a very long article, you might lose your attention, you lose your focus somewhere at the middle, and maybe you'll be very focused at the beginning and at the end. So researchers showed something like that also with LLMs, right? They lose their attentions around the middle when the input length are very long. So it's really interesting what will happen. In LLMs, I don't know like how much the models will become bigger, but I do think that for the new innovations in AI, the new model architectures, my prediction is that they will be bigger than what we see the state of the art models
So you
right
think we're going to continue with the size? It's just going to keep going.
now. I think so.
So let me back up. My question is going to be, how is that affordable for AI to be democratized in that case? Because like you mentioned, you've got to have your own GPUs for inferencing, etc. Bigger the model, the more GPUs you're going to need. Like I stand by my original position that I think trust, and by the way, you're welcome to debate with me on this, but I think trust is still the biggest inhibitor just because there's so many facets of trust right now with AI, from hallucinations to, where's your data coming from? Do you have copyrighted data? To, you've seen what's happened in OpenAI. They kicked the CEO out. He's back. It's because of safety. No, it's because of this or that. It's like, oh my goodness, what are we getting into? Who can you trust? So to me, that's still like number one. But then quickly, I mean, there's so many other things. Then do you have access to all your data? Is it your data that you want to differentiate? You want to keep it to yourself? Maybe that goes back into trust. I don't know. But then comes cost in there someplace. How do you, well, let me ask the question this way. What is your advice for clients right now? You referenced several rule of thumbs, which I think are very interesting, but what's your advice for clients getting into the space that are confused as hell right
Yeah, okay, that's a big question.
now?
So,
That's why I got a big guy like yourself to answer.
but yeah, first of all, I totally agree on the trust issue. Trust is a huge problem, and it comes down to a trust on how your model is actually performing on hallucinations and whether um, you're getting true accurate results from your models or not. And it goes also back to legal issues. Um, can I build applications around LLMs and trust that no one will sue me in the future, right?
Yeah,
Those are
huge,
big
right? Well, by the
problems.
way, IBM indemnifies our models, but we also use third-party models, which look, you're on your own on that. I got to believe customers are really concerned about that. I mean, anyway, but that's the trust piece. We haven't even got to the cost piece, but anyway,
Yeah,
keep going.
exactly. And then you have the cost problem, right? If you're succeeding with AI and you actually you you have a use case which you solve with AI. You bring business value with AI. Then if you're going to scale it, then it's going to cost a lot. We're seeing it with OpenAI, right? OpenAI raised $10 billion for Microsoft a year ago, right? And it all goes to compute, right?
Yeah.
Almost all of it goes to compute. And we're seeing this Gen AI companies, Inflection AI raised $1.3 billion, and Anthropic raising billions of dollars from Google and Amazon. So those companies building foundational models, they for sure are raising billions of dollars for essentially for compute power. And but also any AI company with an AI product, cost becomes super important. And right now, right, like using closed source models with APIs, that's really an expensive solution. Building by yourself open source models, that's something that is doable, right? Like sometimes that's the way to go. And what we're seeing companies trying to build AI applications with closed source models, trying to use APIs, right? But we're also seeing them trying the open source path, right? Taking open source models like Llama 2, deploying them in-house and letting teams to experiment with them and to try to build applications on top of them. And I think for AI leaders, it's important to understand that AI is about a lot about experimentation, right? Experimenting with ideas. I think right now it's not that clear what are the best use cases for AI. There are some emerging use cases like code generation that you mentioned, content generation. So there are some amazing capabilities and real applications, but not for all companies. It's absolutely clear what their roadmap in terms of getting AI to production, right? Like bringing business value with AI. So I think it's a lot about experimenting with different ideas, and with different use cases, with different, trying to solve different problems with AI. So I think just laying down the right frameworks for your teams to experiment fast, to try different ideas fast, because some of those ideas will succeed, but many of them also will fail. So if you're experimenting fast, right, like you're getting faster to results, you're trying more ideas, you can get faster to actual, business
But
value
very,
coming from
but
AI.
but Ronan, very few businesses, I think,
Yeah.
welcome that approach, right? I mean, I agree with you, but to try and fail means cost, and back to cost in a, either GPUs or not. I mean, just that you're putting resources behind it, and you may not get ROI for the investment. And we're in a position now where I think everybody has to take on AI, or you're going to get left behind. There's going to be leaders and laggards. So I've got to do it. Then the question is, how do I do it responsibly to the company? If I'm a senior executive or CEO of, let's say, an insurance company or a financial company, what advice would you give them, though, in terms of how to get this started responsibly? Because you know that there's going to be some trials and tribulations as you go along with it. Not to mention, if I'm taking on some of these foundational models as we've described, there's going to be GPU costs that I have got to take on. Well, what expense should I be thinking? How should I get into it from your perspective?
Yeah. So I think there are three ways to go with AI, with LLMs and Gen AI models. So one way to go is to just build models from scratch, right? Maybe you want to go that route. OpenAI are doing that route. You at IBM are doing that route, right? That's amazing.
That's pretty expensive route, though.
That's pretty. I totally agree. It's expensive. You need talent. You need a lot of engineering power, and you need a lot. That's one route. Another route is to fine tune models, right? Fine tune closed source models with your own data, or go with the open source models and try to fine tune them, and just specialize those models to your use case, to your specific task, to your specific data. And the third path is to just prompt and build applications on top of LLMs with things like in-context learning, doing sophisticated prompt engineering, using methods like retrieval augmented generation, RAG, right? Just taking information and augment prompts with data and proprietary information that you have in your organization. So going with RAG, that's another path. So actually, like prompt engineering, RAG, that's the third path. So all of those ways yeah, are possible right now. And first of all, one of the first decision is, do you want to train models from scratch? Yes or no? If no, then go with fine tuning and prompting closed source or open source models. That's for sure. And then I think, as I said, I think it's about experimenting with different ideas, setting up the right frameworks, setting up the right infrastructure that will allow you to experiment fast, to give your teams the tools, the compute they need to try ideas very fast, so they are not limited by infrastructure. That's part of the things that we do at Run AI. But also, setting up the teams, and hiring the right talent with the right state of mind, having the right goals around experimentations, the right metrics, and building the right culture, and just trying different use cases, different applications, different ideas, and some of them will succeed, some of them will also fail.
On does Run.ai, do you support any model the client brings to you, or select models, or you do the fine tuning, or all the above?
Yeah, so with Run AI, you can bring your own models, you can train your own models, you can fine tune your own models, and you can deploy your own models. You can also bring closed source models and host them on Run AI. We're working right now on also offering open source models out of the box, right? So you'll deploy Run AI and you'll get all the common models that are out there, like Llama 2, Falcon. You'll get them deployed optimally on your own infrastructure, very fast, give access to users, secured access to users within your organization, and letting your teams to experiment with those open source models. So we're going to do also that. Right now, we're supporting any infrastructure, right? Like we can run and be deployed on your own premises infrastructure, on your cloud infrastructure, wherever it is. If you don't want internet connection, we can do that as well. And we're going to have a new offering as well, where we're going to have managed infrastructure. So we see that many startups, like Gen AI startups, they don't want to manage infrastructure. They don't want to manage Kubernetes. They don't want to manage their software tools. They just want to train models, right? Run fast, experiment with their data. So we're going to have this offering of having a managed infrastructure solution as well.
In terms of the shortage, do you think we're headed for AI blackouts?
Listen, we saw that. I think we saw AI blackouts with OpenAI, right? If you remember, a
Yeah,
year ago,
sure.
OpenAI, right, introduced ChatGPT, and there were times where you couldn't get answer from ChatGPT. You would get a response that the model is not available right now, right? That's amazing. That
Yeah.
happened, right? And you had to pay, right? You had to have like a paid subscription to get to be guaranteed to get access to ChatGPT. But we saw AI blackouts with OpenAI. Let's see what the future will bring to us.
What is GPU fractioning? Do you use that?
Yeah, so
Uh,
that's one of the component that I spoke about, right? Like we have the scheduler component, and then we have the
I
GPU
see.
optimization, right? So by controlling the CUDA layer, the CUDA API, controlling access to GPUs, you can fractionalize GPUs. So we can control the access to the GPU memory, to the GPU compute. So essentially, different workloads can get fractions of a GPU instead of a whole GPU. So we're
Makes
essentially
sense.
virtualizing the GPUs at the API level. So it's bare metal, no hypervisor, no virtualization layer like the old ones that brings overhead. We're just sitting at the CUDA layer.
Where do you think we're going to be? Like if we have you on the podcast 3 years from now, I know it's always in this business, you can't predict the future, but give us a shot anyway. What do you think it'll look like 3 years from now? I get you on the podcast and we're talking and we're laughing about last 3 years ago when we had you on. What's changed? Where do you think we are?
I think we're going to see new model architectures. So now we have the transformers. In 3 years, I think we'll start to see new architectures that bring new capabilities. I think more and more people will be afraid of AI. Just the thing. I think it's like it's a real thing, right? Like I'm worried about AI for sure. Fake information, we're going to see that at scale, and it's going to increase with time. Cyber attacks.
That's exactly why I put trust at the top, bar none. I mean, I think that still falls into that bucket, which is a huge concern for me. I joke around. I've said this on the podcast many times. I'm not worried about a cyber being or whatever. I'm worried about trusting these models and fake news and that kind of stuff. You know, the other thing I was thinking about the other day, though, I'm also worried about quantum. And here's why. I feel like there's so much attention on AI right now. The community is forgetting about quantum, which is right around the corner too, as far as I'm concerned. In other words, we're so focused on AI that quantum's over here. It can break cryptography, you know, and I think it will. It's 100% it'll break cryptography. It's just a matter of when. So let's say in 5 years, well, people are worried about AI when we need to worry about quantum just as well, and think about AI in combination with quantum.
Yeah, you might be right. Listen, for me, it's hard to wrap my head around AI.
Yes.
So many
Well, then
things
it's
are
even
happening
harder for
there.
quantum. That's why people
Yeah.
like shy away from it, because it's like, it's not here yet. Well, by the time it's here, it's game over. You know, I mean, you can break
Things change.
cryptography, and everything's encrypted. Text messages, your bank, you know, listings, you know, everything. All right. Well, thank you.
Yeah.
Where can folks reach you and reach your company, Run.ai?
Yeah, so I'm on LinkedIn, I'm on Twitter, and you can find us on run.ai, on our website, right?
Okay.
And, on YouTube, all the regular stuff. Yeah.
All right. Well, thank you for being here. Ronen Dar, everybody, co-founder and CTO of Run.ai. Thank you for your insights. I greatly appreciate it.
Thank you, Hal. I had fun. Thanks.
And for all you listeners out there, hit us on almartintalksdata@gmail.com. Again, we always listen. That's how Al Ronen showed up at our doorstep, and it's been a pleasure meeting him. So thank everybody, and see you on the podcast later.